Okay, so in this example, we're going to use a calculator. Notice that it says sine theta equals 0.8. So it's not an exact value this time. It's not one of our special angles or a quadrantal angle. So we're going to have to use a calculator to approximate what the angle is. Okay? It also says theta is in radians. So we're going to use radians. So right away, you know you're using a calculator and you want it in radians. So set calculator to radians. We don't want it in degrees. Okay, so then what you're going to do is you're going to apply the inverse sine. So you're going to say the inverse sine, so find that on your calculator. You'll probably have to push second function and then the sine button. It's going to open a parenthesis, probably, and you're going to put in 0.8, okay? And it's going to spit out an answer, and we're going to go 4 decimal places. So 0.9273, if I round it off to the 4th decimal place then. Okay, now, remember, when you do inverse sine, that limits you to 1st and 4th quadrants, right? Because that's our definition of an inverse function. It's only over 2 quadrants. And for sine, the quadrants are 1st and 4th. Okay, well, we're not in the 4th quadrant because it's not negative, right? The sign is positive, so we're in the 1st quadrant. And you might be wondering, well, where is that angle? So pi over 2, or is it really in the 1st quadrant? Pi over 2, that's, right there at the y-axis, that's approximately 1.57, right? So 0.9 is, I don't know, like more than halfway, maybe there. 0.9 would be about there. Okay, so it's in the 1st quadrant, and that's what we were expecting to find. But just if you wanted to see it visually, that's what it looks like. You wouldn't have to draw that out. But here's the problem. This isn't asking for the inverse sine. It's asking to solve the equation. What is theta if the sine of theta equals 0.8? Now we know we're not going to get an exact answer. We're going to do an approximation, and we know we're going to be in radians. Okay, so one angle, the angle in the 1st quadrant, is 0.9273. Where else is sine positive? Well, sine's positive over here in the 2nd quadrant, okay? So we need to find that angle. And how do we find that angle? You're going to take pi and subtract, so take pi and subtract 0.9273, okay? So let me do that. Pi minus, okay, and I get 2, this is approximately 2.2143. 2143. Okay? And that would be this angle in radians right there. Okay? So I'm getting 2 answers. Now, it says to solve it, it doesn't give me an interval. So I would assume that they want all of them. They don't have that in the book. They didn't say theta was between 0 and 2 pi, so I would assume they want all of them, but that's not the way they did it in the book. If I were writing my answer, I would write theta equals 0.9273 plus or minus, actually I should say approximately equal to, plus or minus 2k pi, and 2.2143 plus or minus 2k pi. Now, if you go and you reference the textbook, at least the one I'm looking at, that is not how they did it. They went to degrees, which I don't know why they would do that because it specifically says theta is in radians, okay? I don't really get why their answer is the way it is. And there was no restriction on the domain and the directions, so I would include all the answers, but that's just, I guess, the way I would do it. So.